Hello and welcome. This is Matt once again, and I have a couple little quick tips for you, some advanced tips and tricks about grass and foliage. Now I know I just did like a 45-minute video about grass. That was kind of a basic tutorial about how to get it up and running. You don't have to have seen that in order to get this stuff, although if you want to, it's linked somewhere on screen and in the description. But if you just have some grass foliage at all, then this should be a little guide on some tips to take it kind of to the next level, at least mechanically. I know this isn't the prettiest grass in the world, but we're going to do a couple things. One is I'll show you how to get this nicer cold distance fade. You may have remembered from my previous video that we were having problems with it culling away in this kind of blocky mess. That's a quick one. Another couple things are getting it to deform away from the player when you run through it, kind of like you're blowing it out of the way or pushing it out of the way. And then I'll show you how to, if you really want to, do things like deform it out of the way permanently, if you wanted to push it down, or if you want to cut through it when you're walking through it, or, I don't know, make a game that simulates mowing the lawn, if you're into that kind of thing. Or if you wanted to do trees that you can cut down, some ways to interact with individual foliage instances. So let's just get started. The easiest, quickest of these is this better fade. I'll disconnect what I have just to show you what I mean. I really should connect this up here. No, this up here. So by default, it looks like, once my 5 billion shaders compile, I've been getting a lot of bugs recently where it says there's 5 billion shaders or negative 150 shaders or that kind of thing. I think it might be engine version 4.19 doing it. But now it culls away in these blocky chunks. And previously I'd been dealing with this by like having 3 different foliage types, each with a different set of parameters for cold distance. That was kind of obnoxious to do, and you had to set density on all 3 of them, and just not a lot of fun. Turns out, nobody tells you this when they do grass tutorials, and it's not really very obvious in Unreal's documentation unless you dig for it, but there is a secret parameter. It's not secret, but it's called per instance fade amount in the materials. Literally just per instance fade amount. And this applies specifically to instanced static meshes, and only instanced ones. There's one specifically for static meshes. Any static mesh, if you place it in the world, you can specify a I don't know where it is, but there's a number in the details you can specify that it's like its desired render distance. And then if you package a game and you have an options menu, or you want to play around in the editor view settings, then somewhere, I really should come more prepared for this kind of stuff, but show settings, is it engine scalability settings, view distance. It'll be controlled by view distance. And in all materials, you could use a node similar to this per instance fade amount if you wanted to. But regardless, plug per instance fade amount, multiply it straight by your regular opacity mask that you're using for your grass, and that'll get you pretty far. I did one more thing, which is that I then multiplied that once again by this linear gradient. If you saw my other tutorial, you're probably familiar with these, but by default, a vertical linear gradient looks like this. With black on the bottom, or sorry, black on top. And we want this fade to start from the top and go to the bottom. And so we do this 1 minus to kind of invert that. And because this is fade amount, we want full fade amount at the top, black at the bottom. And so I then multiply that one more time by that, and that means that it fades from the top down according to this opacity mask, and you get this much better smoothing. And you can imagine that if my landscape material was set up and it was the right color, then you wouldn't even notice this from the perspective of the player. It also enables you to really crank the cold distances down so that you're rendering less grass at a time, and that's just going to give you better performance because you don't have this pop in that you have to hide. So that's the easy one, quick tip number 1. Number 2, what if I want this grass to move out of the way, to deform when I run through it? Well, there's a couple ways you could do it. The way that probably comes to mind is that you could, sorry, I'm looking for something here. Okay, yeah, that's disconnected as it should be. Is that you could set up the grass to do collision and then when you collide with it or you overlap it, you like push it away from you, rotate it, that kind of thing. And that's, you know, a way that you can do it. It gives you a lot of control, and I'll show you how to do that, because if you do want to do anything advanced, then that's how you have to do it. But for something as simple as like deforming it away from you, that's actually something you can do in the material, in the shader itself, with a special thing called a material parameter collection. You're probably familiar with material instances, because they allow you to expose parameters at runtime, things like grass tint. If I want magenta grass, I can do it. A material parameter collection is just a blueprint that stores a bunch of these, but that any material can have access to. So I've been playing with cell shaders lately, and one thing that I might want is for every material to have access to my light color or my shadow color, that kind of thing. So you can pass materials, or you can even pass scalar parameters in to do various things with. So really cool. You can use them for some tricky things that might not be obvious. That not that they don't tell you about them, whoever they is, but that are a little bit counterintuitive. So for example, I've got this material parameter collection, which I have not even bothered to rename, and I have in it a vector parameter called player position. Because vector parameters have 4 channels, they're meant to store like a color, 4 channels from 0 to 1, but they're stored in the same way that any other vector is in Unreal Engine. So you can pass in information, actual like position information. And that's a good way to get things like position information into a material to do something with. You could use it to do like a sphere mask, or to show the player through walls by controlling the player position and then making materials have an opacity mask based on camera position and player position, like Diablo style, that kind of thing. We're going to use it to deform grass away from the player. And the way we're going to do that is in here, in our grass material, we can take a collection parameter in which you specify which material parameter collection you're using, and from it which material or which parameter you're using. Pretty easy. So now we have access to player position in our material. Kind of. We have to actually set that parameter somewhere. I'm going to set it in third person character in my character blueprint. All you have to do is over in tick. We're going to set it per tick. In reality, for optimization reasons, you usually want to refrain from doing a lot in tick that doesn't have to be done in tick, because things that happen per frame add up computation-wise. This is one of those few times where it kind of makes sense to set this per frame in a lot of cases, because this is like a global parameter that any material can access that you probably do want to have constantly changing. You probably do want to do a little bit of logic though. You know, in reality, you'd probably check, am I in a level that has a lot of grass? If you have some other logic existing that tells you if you're in a building, or like checks ground material below you to see what kind of footstep to play, you may be able to use that to do something like only set this value if we really need to. Or you could check if the player has moved since the last saved position they were in, and you don't have to set it then, that kind of thing, just for efficiency. But for this little prototype, we'll just set it once per frame. You could plug this in here. I've got a sequence just because I've got some other logic going on. But so now we have capsule component world location, and I just plug that right into the set vector parameter value. Once again, you specify the parameter collection and the parameter that you're setting. I'm setting capsule component specifically, and I'll tell you why in a little bit. So we've got our player position. Now what do we actually want to do here? We want to, in a radius around the player, we want to push mesh vertices away from us, controlled by some strength, some gradient. So we need to get the distance to the player, and then when the distance is below a certain threshold, we need to start ramping up intensity of this like effect. And then we also need to, based on that intensity, based on how much push we're going to do, we need to like apply an offset in the correct direction and the correct distance. So let's do that one step at a time. First, let's get distance from the player to whatever piece of grass we're looking at. We take our parameter, our position. It comes as a 4 vector, red, green, blue, and alpha, because it assumes you're going to be playing with colors. We only need R, G, and B, X, Y, and Z, because world position is a vector of 3 components. So it's very simple. We just get the distance between them. Easy peasy. That spits out a number. And when we're closer than a certain threshold, we want to be applying effect. I'll show you with a little if node, to follow along here, but we'll say if distance, and we're going to compare that to the number 200 in this case, and if it's greater than 200, we'll just apply our regular material, regular base color. And if we're closer than 200, we're going to take I'll just take a vector, it doesn't have to be a parameter actually, a color, a nice magenta, pink, there we go. And we'll make the grass pink if it's closer than that. So now we're checking, and I'll plug that to base color, just for fun. So we're checking the distance between the world position of the pixel we're looking at and the player position. And if that distance is greater than 200, we're doing nothing, and if it's less than 200, we're drawing pink grass once the shaders compile. So now I have this pink grass around me, which is pretty fun. You get a little preview of the effect we're going for because I still have it plugged in down there, but it's only affecting the pink grass. So you can imagine I can use this kind of thing for a lot of effects. Like I said, showing like a hole in walls if I run behind one, like a Diablo style, that kind of thing. What we're going to do now is we can tell if we're in that 200. I'll plug that in, and I'll plug my base color back in. I'm going to go ahead and compile those shaders just so I don't have to do it again. So what we're going to do, we now need like a gradient that gets stronger, starting from 0 on the outside of that circle and going to full strength once you're on the player. And to do that, we're going to just take our distance and then divide and clamp. And the effect of dividing and clamping is that anything farther than in this case 200, say 250 divided by 200 is going to be greater than 1, and so it gets clamped. We do nothing. Numbers inside that range, 150 divided by 200 is like a fractional amount. So we now have this gradient, and it only applies inside the circle. It's the opposite of what we want, like 0 divided by 200 is 0, and so we have no strength right on top of us and full strength at the outside of the circle, but we can just do a 1 minus note in order to invert that. So now we have this sphere around the player where there's 0 intensity on the outside, full intensity on the inside. And that's going to be our effect strength. And then the last thing we want to do, because this is grass, because it's rooted on the ground, what we're going to do is the same thing we did with wind, the same thing we did with faking shadow color, and that is to take this inverted linear gradient, squared in this case for extra intensity, and we're going to multiply that so that this sphere of influence also affects the tips of the grass blades more strongly than it does the base, because we don't want to push the base of the grass around, we only want it to push the tops. Okay, so we have our effect strength gradient, and now within that we need to get what direction we're pushing and how far we're pushing. For direction, what we can do is a little bit of vector math. We can get a vector from the player position to the bit we're looking at, the bit of grass we're looking at. That's going to be the final minus initial, or world position minus player position. And that gets us a vector from our player position to the world position of the pixel we're looking at. We're normalizing that so that we don't really need we don't need to know how long that vector is, we just need its direction. So normalize makes that a unit vector, length 1, starting at our player and pointing in the direction of the pixel that we're going to be pushing. That's good because we want to be pushing it away from the player anyway. And now we need a force, or a distance. Because this is grass on the ground, once again, we don't really want to push it on the z-axis. We don't want to push it up or down, we just want it to go out to the sides. And so we can take a strength, and we can make a vector out of it, appending, we're going to append it 3 times, or twice rather, so that this one gives us x and y, both of which are 100, and then we throw a 0 on the end. So we have this vector of 100, 100, 0, because that's the amount of strength that we want. And these are parameters. So now we have the direction, we can multiply that by the strength, and then we multiply that by the effect strength. And that gets us our final world displacement. I know, this is a longer video than I wanted it to be already. Okay. And finally, just for kicks, we're going to take that world displacement and we're going to add it right on top of any that we already had. In this case, I'm already doing wind for world displacement. So I'm going to add this right on top. Throw that into world position offset. Boom, bang, done. Whew, fun. And now the grass moves out of the way when I run through it. There's a couple things you can do to make this effect a little better. In my case, I'm going to full screen it just so you can see. The frame rate's going to drop a little bit because I'm recording. So the grass moves around a little bit. In my case, I've got a couple things that make this effect a little bit wonky when it's just like one piece. You notice if I go over here that it kind of stretches a little bit. Not in too obnoxious a way, but it's a little obnoxious. This is caused by two things. One is that my grass texture is kind of like flat planes. It doesn't really look like blades of grass. It looks like a sheet. And so deforming it acts a little funny. More importantly, though, is that my actual grass mesh is a couple of straight planes. And because I'm deforming the vertices, there's not a lot of vertices to go on. Each one of these is just, each one of these planes is 1, 2, 3, 4 vertices. And so I'm just like pulling 1 or 2. And this comes to a principle in general. I can change my view mode, optimization, and check shader complexity. And white is bad. This is something I talked about in my other video, but these squares are the actual planes of my mesh. And for performance, you want the opaque parts of your masked material to take up as much of the space as possible. So if this was optimized, then this grass would be much bigger on the grass plane. That's just a UVs thing. And also you could reduce overdraw by kind of tailoring the shape of this, adding more vertices to kind of go around it. So I could do 1, 2, 3, 4, 5, 6 instead of 4 verts, that kind of thing. It'll make UVs a little harder, but and that'll reduce overdraw even more. I would recommend having levels of detail, right? So just a plane would be a far level of detail because you're not deforming those vertices anyway at far distances. And then you could have a higher level of detail up close that even can cut into these grass blades a little bit just to reduce that transparency overdraw. Because triangles, the number of tries you're drawing isn't really the issue so much as the size of the tries you're drawing. So if you're very stringent about the levels of detail here, then you can get pretty good efficiency gains. So I would recommend say making 3 levels of detail for your grass, one that goes up and into your big chunks like this, one that goes around it, and then one that is this square. And transitioning to those very aggressively. And for doing wind and for doing this offset we're doing, it'll look a little better if you subdivide it a little bit. If you have some extra vertices in here other than just the edges of a plane, for your high levels of detail anyway. Because the issue is that I'm only pulling around 1 or 2 vertices at a time. Like I said, it looks pretty great when you're just running through grass, right? That's no problem at all. But just to kind of bring it to that next level, that's what I would do. Legend of Zelda does this, the new Breath of the Wild, which I've played a lot of. It's very fun. And Epic's own Fortnite does this kind of grass deformation. I happen to know, do it with this vertex shader method. So this is not unfounded, this idea. Okay, so I know that was complicated and long. If you did not understand it, that's okay. You can feel free to copy this node for node, and no one will judge you for it. It's okay. Next up, what if you may be saying that's great, but what if I want to do more than just push grass away from me around the player? What if I want it to stay deformed and stay matted down, or what if I want it to get cut out as I run through it, or I can stomp on it and it destroys some grass, or what if I want to play Legend of Zelda and slash it with a sword and it destroys the grass and then lizards pop out and I can collect them or whatever. Or what if I want to chop down trees? Well, you need to be able to detect individual instances of grass here. And so you're going to get an efficiency trade-off because you're going to have these check collision. It's not that big a deal, but these things add up. And even things like this little player offset effect add up in the shader complexity. I took this material from 119 instructions in the base pass to 131. This distance node does a square root operation, which is a little bit intense. So these things add up. I'll probably do some tutorials pretty soon on optimization. understanding these numbers down here, understanding the stats that you have available to you and what affects performance and CPU versus GPU and that kind of thing. But just know that grass that doesn't move or that just has wind is going to be better than grass that is using this material parameter collection and updating the parameter in tick and that kind of thing is going to be, and that's going to be more efficient than checking collision. So let's do collision. I'm going to unplug this and hit apply. For now, I'm going to do it very simply and just like delete grass that you walk over. So we take our static mesh, and I've done this already, but you have to go up to collision and add some collision. Probably just one. You don't want to get fancy here and actually have advanced collision. You could shrink this in if you want it to be a little better. I'm just going to leave it this way just so that it's kind of exaggerated. And you can go over to collision here, set collision to query only. You don't need physics. You don't need this grass to roll around, be physics simulated. You just need it to check for like overlaps and ray traces and stuff. And then what I've also done, because I've set it to custom preset and then there's object types, foliage isn't here by default. And none of these types are really great. World dynamics probably okay. But what I did is I went into project settings, project settings, and under collision, you can make more object channels. So I just made an object channel called foliage, just to make this a little easier. And then I set this to be of type foliage, and by default it ignores everything. Step 2, oops, I just opened Chrome again. So you're probably going to get some frame drops in OBS. Go into your foliage tools, and under your instance that you're using, you can down in collision. Once again, set it to custom, set it to query only, and in this case it ignores everything except that it overlaps with pawn. And pawn, because my collision capsule in my character is collision of type pawn. So we're gonna generate overlaps with my character's collision capsule. Okay. Finally, third person character, we can take this collision capsule and I can say on component begin overlap. You can do this a couple ways. You can check for collision in multiple ways, but on collision begin overlap capsule component. Now you might think that the way to do this would be to just like say, well, the other component I hit, I want to get rid of the grass, right? So I can just set it to be invisible, set visibility to false. And well, I mean, I guess it kind of works, but not really, because foliage is what's called a hierarchical instanced static mesh. Instanced static meshes are like regular static meshes, except that they only have a transform. They don't have, you can't set materials separately. You can't set like instance settings like visibility separately. But in exchange, instead of having to do 19,000 draw calls for this scene right here, it does one draw call for this grass. And that is an astounding performance gains. This is how you can get massive amounts of meshes, stuff like asteroid fields, or lots of foliage like grass. It can become hard when you're dealing with these instance meshes to do collision. Like, I can't really check just one of them, can I? I mean, I guess I could like check if what I hit was cast to foliage instance static mesh, and then I could do something there. What we're going to do is we're going to say cast to instance static mesh component. You could probably cast a foliage one. I think that's a subclass of this. And then as that, we've got a couple options. What we're going to do is let's see, remove instance. And you have to remove instance by its index. Thankfully, in these collision tests, in component overlaps and hits, this other body index, or in line traces or sphere traces, if you break the hit result of that, that is also hit item, is going to return the index of the instanced mesh if it hits one. So we can say that if we hit an instance static mesh component as our other component, then we can remove that index. And now, if I've set everything up correctly, yay, we're deleting grass as we run through it. Like I said, if you wanted to accomplish the same effect as before, but have it say like stay deformed or slowly return to its original position or something, you could can do this. This also has a get instance transform. And you can set instance transform as well. Oh, you can set cull distances. I didn't know that. Reset transform. Come on, where is it? Update instance transform to a new one. So you could break this, and then you could give it a new rotation and position. So for example, you might combine these effects, have the vertex shader do a little bit, and then you could, when you hit something, you could rotate it a little bit out of the way. Or you could even use this vector interpolation to like smoothly rotate it out of the way, that kind of thing. Note that this is going to, like if I play and then I delete some stuff and then I exit play, then it doesn't save that. That's not saved to the level, so you'd have to do some complicated stuff. I'm not totally sure. You might be able to like do something crazy like on save. You could iterate through every instance and then check which ones exist, and I don't know. Regardless. You could also use that to do things like cutting down trees. The method you would use is like, you have a bunch of trees which are instances, and then when I hit one with a line trace, with an axe, that kind of thing, you could check if what you hit was the thing that you thought, instance to static mesh component, or and then you can get mesh, get static mesh, and check if it's equal to something. So that you could check that I hit this tree and not this grass, because you'd want to do different things. And then I could say, if I hit that grass, I want to get instance transform. Oops. Instance transform, and then I could use that to spawn a special tree that can be chopped down. Like I can make a blueprint that's a tree just like this one, except that it has some event that lets it be chopped down. Maybe you've got it like a destructible mesh that you can actually chop pieces out of it with an axe. And then in my tree tutorial I was using treeit, and that allows you to export like two parts of a tree. You could export the trunk and the top, and then when you hit it, you get its transform, you spawn your new tree actor that's choppable, your like special blueprint, and then you do whatever you were going to do, like destroy it, chop it, tip the top part over, that kind of thing. But that way you don't have to spawn 11,000 special blueprints with that functionality, because the player is only going to interact with one at a time, and they're probably not going to interact with most of them anyway. So you just replace them when you have to with your higher overhead actors. Okay. Ooh, this is like 3 times as long a video as I wanted it to be, but those are my tips about doing grass and foliage. 1, you can do cull distances better. 2, you can do vertex shaders with material parameter collections to do deformation. And 3, if you have to, if you want to swing swords through grass or cut down trees, then you can have them do simple collision, and then you can use this body index when you check hits and check overlaps in order to perform operations on those instances specifically. That's the video in 10 seconds. Like I said, I may have some videos coming soon about some basics of optimization. I know in the last one, if you saw it, I promised I would do some stuff with material layer blending, landscapes, and tessellation and stuff. Here's a little preview of that. So stay tuned. Thank you for sitting through the end of this one. And I'll see you next time.